Hello everyone and welcome to this video. This video is the start of a new series where we'll be making a game with Pygame. Now this type of game is called a platformer. Now a platformer is a game where there are some platforms and you have a player and that player has to get to the highest kind of height on those by jumping on those platforms, and if the player falls off, then it is game over. Okay, so we're going to make a game like that, and we are not going to be using anything like functions. So we're going to be using object-oriented programming for this game. So I use this in my blackjack game in Python. So yeah, we use object-oriented programming in that game. So we use classes and special magic methods and stuff like that. So it's pretty good using object-oriented programming because you have kind of more opportunities when you're using it. So we're going to be using that in our platformer game in Pygame. So first, I want to show you a preview of what the game will look like once we have finished playing it. Okay, so I'm going to be showing you how it looks like. So let me show you. So here we are. This is the project. This is the game. So if I have to run this, so I'll run it. Whoops. There we go. We have an animated player and we've got animated enemies too, and pretty good graphics. We've got sound effects as well, and we have a scrolling background with clouds. We have power-ups as well, and if we fall off, it's game over. So I'll find the power-up and show you what it does. So you can go pretty high. And it has some sort of scrolling effect when you fall off. So yeah, this is the game. It looks pretty simple, but it's actually kind of hard to make because we're going to be using some kind of advanced stuff. You can also kind of jump off the side and land on the other side, like that. And I collide with an enemy off the screen. You can do that and you come off the other side. So yeah, that is the game. So now we are going to be making our game. So let's actually start. So here we are. Now this is our empty project. Well, it's not exactly empty because I have this Pygame template. Now I have a video on how to make this Pygame template. Now this Pygame template is basically a template you can use for any sort of game. Now it has all the key features you need, so like the width of your screen, the height of your screen. It also has an FPS, which means frames per second. We've also got some color definitions here. These are probably the main colors you need, especially white and black. We've also got an all sprites. So this is equal to pygame.sprite.group. Now I have never introduced this to you before, but Pygame has some sort of thing called Sprite. Now this lets you handle sprites. So we create a sprite group, and now we can handle all our game characters and sprites together with only one function call. Now here we initialized Pygame and created a window. So we initialized the audio system of Pygame. We also initialized the sound system. This is the audio system, sorry. We initialized the audio system and the video system. So, and we also created the screen, and we also added something called a clock. So that was pretty simple. And then we have our main game loop, and it has these key sections called process input or event handling. We have the update section and a draw section. Now I'm going to, I'll explain all of this in the video of how to create this Pygame template. So yeah, don't worry about that. And then we've got pygame.quit at the end. So basically, when we're using classes, it will get pretty messy because we're using classes and classes are pretty big. So we are going to add some sort of organization into our work, into this project. So I'm going to be creating a separate file called settings. Now this isn't going to be our main file. This will just contain all our game attributes and settings and options. So such as these color definitions and the frames per second, width and height. And soon we'll be adding lots of things to it, but not too much. It's just the attributes, remember? So we're going to be creating a new Python file called settings. Okay, so settings. .py. So if you're in PyCharm, there is such thing called split screen view, and you can also do this using Atom and maybe Visual Studio Code. So I'm going to go into split screen view. So all you need to do is select both of these and press Ctrl D, and it will have gone into split screen view. So this is our empty settings. So we don't need to do any importing here because it's only the game attributes and settings. So let me just write that up here. So game attributes. You can also call it settings if you like. I'm just calling it attributes because it's more like an attribute. And you can also call it options as well if you like. So all I'm going to do is I'm going to cut these, copy and cut. But don't do this if this is your only copy. I would recommend just duplicating that Pygame template that you have made and then cutting from there, cutting from the duplicated version. So I'm just cutting it because I have loads of copies of it. Well, actually, no, I just duplicated them. So I can just do it easily. So here, these are basically our settings. And we are actually going to make our screen a bit bigger because this is only just our... This was only just our Pygame template. That's just for example sizing. So I'm going to set the width to 480 and the height to 600. So that was the same kind of size of the screen in the preview. And then I'm going to set my FPS to 60 because I don't want to introduce any lag in my game. And since this is a platform, it will get pretty frustrating. So that is basically our settings. And now, once we have created our settings, we are going to create the main file of our project. So new Python file. I'm going to call this main. So most people call their project main file main, so they know they know which ones are the main files and which ones are not. So this is going to be our main file. So we are going to use all of this code here now to put into a game class in our main.py. So again, I'm going to go into split screen view. And that would be, and now we can do things we want. So at the top here, I'm just going to write a comment saying infinity jump. So I was actually planning to call this infinity jump because it's like infinite. The platforms will generate infinitely. So that's why I'm calling it infinity jump. And this is a Pygame platformer. Okay. So first we want to put these import statements there. So the reason I imported random is because you would want to actually have some sort of randomness to give your game a natural feel when whether or not you're using enemies or clouds or anything that you want to be random, then you use the random module. And you'll see a lot of random kind of things in games with Pygame. Loads of people use the random module because they want to give a natural feel to their game. They don't want it too specific and kind of weird. So that's why they use the random module. Okay, so as I told you, we're using classes. So we're going to be creating a class game. Now we don't need brackets for this because it's not a sprite, so we don't need brackets. So this is a class game. So we're basically going to be using all of this code to make this game class, all of it. So the first thing you want when you're using a class is a init method. Now this is basically the main attributes you want in your game. So we'll also initialize Pygame and create the window here. So we're going to write path for now. Later on we are going to fill it up. We also want a method called new. So this is our own method. We're going to create this new. So this method over here is to start a new game. Okay, so this is where we start a new game. And after that, we want a run method. So this will actually be our main game loop. And then, so this run will basically be all of this. But we're going to make it easier to write down by creating these events, update, and draw sections separately. Okay, so it's a bit cleaner. So we're going to say def events. So we're going to put that one first. Now this is event handling. So we'll put game loop. This is the event handling, or you can call it process input section. Okay. So after that, we want to put the update section. So def update. Now this section, as I told you before, so the update section, as I didn't tell you before, is the section where you handle the sprite's behavior. So I'm just gonna write game loop update, but it'll be pretty easy to remember that it handled sprite behavior. Okay, so it doesn't update anything, it actually just handles sprite behaviors. So it's kind of misleading to call it the update section, but that's what we should call it in Pygame. So after that, we've got another important method called draw. Okay, so this is the game loop draw section. So game loop draw section. And then we're also going to add a few extra methods called show start screen, and we're also going to put a show game over screen method. Now we're not going to be filling in these methods in this video. We're going to be doing it in the next video. Okay, so not in this video, next video. So it's pretty obvious what these methods are, but I'm going to write down comments so we know. So this is the game start screen, and this bit is the game over screen. Okay, so that's game start screen, this is game over screen. And then we should add a kind of main game loop thingy. Well, not really main, but kind of like a tiny game loop. Okay, so what we're going to do is we are going to say if name is equals to main. So this is actually pretty confusing if you look at it, but this is actually kind of important. So usually I would have used a while loop, but I thought I would do it a little different and use this statement. So this basically means if the name tag is equal to main, which basically is telling the computer to run the game. So if that name tag is equal to basically running the game, then you want to run the game. Okay, so if name is equal to main, so if it's equal to that main statement, we want to run the game. Okay, so loads of people use this in advanced things, so that is why I'm using it now. You can use a while loop if you want. It's not really going to make much of a difference, but I'm going to be putting a tiny while loop inside this if name is equal to main. Okay, so if the name is equal to main, we're going to say G is equal to game. So is equal to this game class. Okay, or actually we'll say game is equal to game. Okay, remember to keep your variables very meaningful. So we're going to say game.show start screen. Now it's not going to show start screen because we haven't filled in the method yet, but we're putting it before our while loop because we want this to be the first command that it executes before the actual game loop starts. Now once we've done that, we're going to say while game.running. Now we are going to create that variable. So that while game.running is basically this bit over here. So while running, well, we're just going to say while game.running. So while game.running, you want to do game.new. So we want to start a new game, and then we also want to do game.show game over screen. Okay, so we want to do that, and remember to format everything correctly. And then last of all, and it's also very important as well, we need to say pygame.quit. So basically what we mean here is if none of this happens, we just want to make sure we don't run the game accidentally. So that's what we want to do, okay? So now let's start filling up these sections. So as I told you, the init is basically initializing Pygame and creating the window. So all we need to do is we just need to copy all of this. And then pasting it here. So we need to correct some things here. So we need to say self.screen is equal to pygame.display.setMode, width and height. And then we need to say self.clock. Now, why is this coming as an error? Have a think about it. Well, the reason it's not coming is because the variable width and height on it in there. But we can make sure we reference to them by importing our settings file. Yes, we can do that if it's in the same directory. So we're going to say from settings import all. Now the reason we are saying this is, the reason we're not just saying import settings is because if you write that, it will still come as an error unless you write settings.width. And we don't want to keep on writing settings.width all the time. So we're just going to say from settings, import all. Okay, so just want to import everything from settings so that we don't need to keep on referencing it. So now that we have filled in that, we are going to have the new section. So this is where, so let me just cut this bit out actually. So new is where we start a new game, okay? So yeah, but before that, I'm actually going to create a variable called, let's create it at the end. I'm going to create a variable called self.running because I'm going to say self.running is equal to true because I said while game.running, but I hadn't created that variable yet, so I'm just creating it here. So self.running is equal to true because you want it to be true if we want to run the game. So in our new section, what we want to do is we want to create our all sprites group in the new section because every time we start a new game, we don't want the sprites to stay where they were in the previous games. So we're just gonna keep on creating that sprites group whenever we start a new game. So we're not gonna say all sprites, we're gonna say self.allSprites is equal to pygame.sprite.group. And we also want to call the run method, so self.run in our new, because since it's going to be starting a new game, we want to be able to run the new game. So we're going to be putting self.run here. And now here we have to do the main game loop. So this is actually isn't actually hard because we already have the events, update and draw sections. So all we need to do here is we are going to create a variable called self.playing. So why do we need to create a self.playing variable when we have the self.running? Well, self.running keeps the window on the screen, But self.playing determines whether the user is still playing or not. So if they're not playing, we're gonna actually go to game over screen, so it's not too bad. So I'm gonna go to game over screen, okay? So we don't want it to only go when it's running, because since we're going to be adding game over and start screens, we are going to be putting a self.playing variable in there. So we're going to set self.playing to true, because we want that when it's running. So we're going to say while self.playing, we want to call the following methods. So we want to do self.clock.tick. I'm going to make it tick at a certain FPS. Okay? So our FPS, we want it to tick at a certain FPS. And then we're going to call the self.events method. We're going to call self.update and self.draw. And that is basically our game loop right there. Next, we need to fill in the event section. Now this is event handling, right? So it's not going to be too hard. All we need to do is we need to copy this bit. So it's not too hard, we just need to copy that. So I'm going to copy that and paste it right there. So we are going to say self.running is equal to false, but we also want to set self.playing is equal to false, because the game's only going to show up there if self.playing is equal to true, and we don't want to frustrate the user by only saying self.running to false, because the game might still be going on and it'll frustrate the user. So we want to set self.playing to false as well. So yes, we are going to do that right now. So all we need to do is, before we set self.running to false, we're going to say if self.playing. So we only want to set self.playing to true if we only want to set self.playing to false when it's set to true, because it would make no sense to set it to false when it's already false. So we only want to set it to false when it is set to true, okay? If you understand that. So we're going to say self.playing is equal to false. Whoops. False. There we go. And then our update section is basically the update section in our Pygame template. So basically we need to do all sprites.update or self.allsprites.update. So I'm just going to put that right here, and I'm going to say self.allsprites.update. And then the draw section is this section over here. Okay, so we need to say self.screen.fill black. We want to draw all our self.allsprites onto self.screen. And then we also want to flip the display after doing everything. And that is basically it for the basic framework bit. So now we can discard the Pygame template, but don't do it if it's your only copy. I wouldn't recommend doing it, but if it isn't, then just discard it. So I'm going to delete that. And now in my settings, I'm going to be creating a variable called title. So this is going to be the title of my game. Now I'm going to call it infinity jump. Okay. And now in our main.py, we can set the caption or the kind of name of the window to the game title. Okay. And let's check it out. So I'm going to run main. Okay. So it says game attribute has no attribute screen. Well, I need to spell it correctly. There we go. So now we have our window, which is ticking at 60 frames per second, but we can't really see it, but it actually is. And yeah, it's pretty good. So now what we want to do is, since we have already created the window, we're going to be adding a player to it now. So as I told you, I'm going to keep things organized in our game class. So right now, I'm just going to collapse all of this. You can do this in PyCharm and Atom and Visual Studio. Loads of IDEs have this collapsing thing. So I'm going to collapse it all. I'll collapse this too, okay? Just to keep it neat. So now I am going to be creating a new folder. Not folder, sorry, a Python file. I'm going to call this one sprite.py. So we're going to handle all our game sprites in here, okay? So we are going to be adding a player, which is just going to be a rectangle for now. We're not going to be adding any actual graphics now. It's just going to be a plain rectangle, but it's still, and we're also going to be adding realistic movement to it. So we are going to say import Pygame, and then I'm also going to say from settings import all. So because we're going to be using some things from settings too. So we're going to be creating a player class for our player. So we're going to say class player. We're going to identify our player as a pygame.sprite.sprite. So we're going to identify it as a Pygame sprite so we can add it to our sprite group. So what we're going to do is we have to obviously add some attributes and initialize our class. So here we're initializing our Pygame class, but when it comes to sprites in Pygame, you also have to initialize the whole sprite itself. So we need to say pg.sprite.sprite dot init. Whoops, I have written pg. Oh well, so all we can do is we can say import Pygame as pg. So now we can reference it to as pg. So we're going to say pg.sprite.sprite and that should be fine. So we're going to initialize it, right? And we need to pass in self over here because we want to initialize the sprite and not anything else. So we are going to create a self.image variable. Now we're not actually going to be adding an image. We're just going to put that there. So we're going to create this as a pg.surface, or maybe you can call it a rectangle. But I'm going to be calling this a surface because I want a kind of rectangle. I'm going to create this a 30 by 40 pixels rectangle. And I'm going to say self.image.fill because you can't fill rectangles. You can fill surfaces though. So we're going to fill it into a yellow color. Now basically, we need to create that color in our settings.py. So we need to say yellow is equal to, that is basically maximum red and maximum green and no blue, okay? So that is the color yellow. Now we should have a yellow image. We also need to create a rect. So self.rect is equal to self.image.getRect. Now, when I started learning Pygame, I had no idea why you needed a rectangle for your image. Now, basically, we need this rectangle because we can't actually move the image, but we can move the rectangle containing the image. So this is how we do movement because we're only moving the rectangle. We're not really moving the image. So yeah, that is why we need a rectangle. So you can move the image, calculate collisions, and do more exciting things like that. So we are going to position our player. So we're going to say self.rect.center is equal to. So we're going to say width over 2 and height over 2. So you might be thinking, what's self.rect.center? So basically, if I open up, I'm going to open up Paint here so I can demonstrate to you. So let us say we had a rectangle, yes? So that's not really a rectangle. I'm going to actually create a perfect square. I'm going to try. I'm looking at the things to see. There we go, that's a perfect one. So we're just gonna give it a thin outline. There we go. So the self.rect.center is basically this point over here. So if I zoom in and go to the side a bit, the self.rect.center is this little point over here. Okay, so if that is self.rect.center, this whole bit over here would be the top. Okay, so that would be the top. This would be the top left, this would be top right, and this would be mid top. This would be mid bottom, and this whole side would be the bottom. This would be bottom left, this would be bottom right, this would be left, this would be right. Okay, so yeah, that's basically what they are. Okay, so this is self.rect.center. We're going to position this so it's exactly in the center. So I'm not going to save that. So in our main.py, we can actually add that to a sprite group. So in our new section, in our main.py, what we're going to do is we are going to be doing the following. So we are going to be saying player is equal to player. Now basically it's giving us an error because we haven't imported the sprites. So we're going to say from sprites import all, and that should do it. There we go, we have no error now. So we're going to actually say self.player. So we're going to, after that, we're going to say self.allsprites.add. We're going to add self.player to all sprites. So let's see if it shows up. So yeah, here we go. We have our yellow rectangle, but now we want to move our rectangle, okay? So let's start moving it. So basically, we can look at movement using something called update. Now, update is actually from this sprite.py. So that sprite.py handles all our sprites. So so here you can see an update is the method to control sprite behavior. So yeah, that's what it does. So def update. So basically, what we want to do is we want to move our player, look at the key presses. So how it moves. So basically, we're not going to look at key pressing now. All we're going to do is just going to be moving the player by itself. So we're going to say self.rect.x, so the x coordinate. So we're going to be moving it along the x-axis, not the y-axis. Is it plus equals to 10? And now it is moving extremely fast. Let me just maybe put it slower. 3. That should be fine. There we go. Oh no. Oh. I need to run again. Stop and rerun. There we go. So you can see it is moving to the side. So we are going to be moving our player now. So when you're moving your player, we need to kind of calculate keys, right? So we're going to say keys is equal to pg dot key dot get pressed. So if we try to print keys, I will open my this up. You can see that it is now giving lists and lists and lists of nothing. So if I press C, you can't really see it. So I'm going to press all of the keys, and you can't see it because it's going so fast. So basically, it returns the keys as a list, okay? So big lists, it returns all of the keys as those lists. So there must be at least 100 characters in those lists, because there's actually a lot of keys on a keyboard. So it'll return that as a list. But we don't want that to happen. We want to handle those keys. So we need to index into that list and find out which key is getting pressed. So we're going to say if keys, so we're going to index to the pg.k left. Okay, so that's the left arrow key. Or you could put kw. I personally don't care, but I'm just going to put left and right because I'm more comfortable with those. So I'm going to say self.rect.x, maybe not 10. I'm going to say minus equals to 1. So basically it's going to move to the left, not to the right, because we want it to move in the correct direction. So we're going to, after that, we're going to say self if keys, we're going to index to pg.k right. If that is the key, then we're going to say self.rect.x plus equals 1. So let's check it out. So now you can see it's moving nicely, slowly, or whatever you want, but it doesn't look very lifelike. So that is what I meant by realistic movement earlier. So I want it to be some sort of lifelike movement. So how can we add lifelike movement? So basically we need to add something called acceleration. Now acceleration is the state of, let's say you are running really fast across a field. Now you can't just stop immediately. If you want to stop, you can't just stop immediately. You somehow just go slowly first and then you come to a stop. So that's what acceleration is. You want to add that to our play because right now our play is moving, is just stopping really quickly immediately. So we're going to add some sort of light acceleration to it. So I'm going to, in my settings, I'm going to add a section called player properties. Okay, so I'm going to be adding that. So in my player properties, I'm going to say player ac, which is basically short for player acceleration. I'm going to set this to be equal to 0.5. Okay, so basically we can, in Pygame, we can use vector2 values to implement acceleration. Now vector2 is kind of really complex. It's a very complex math thing, so it's gonna take a lot of time to understand. So I'm going to say vec is equal to pg.math.vector2. Okay, so now what we can do is we can create a few things here. So we're going to create 3 vector2 values. So we're going to say self.pos, which will be the position of our player. So now we're not going to be moving the rect, we're going to be moving the position, but that will still be moving the rect. So we're going to say self.pos is equal to a vector value of, so these are the parameters you need to pass in. So the parameters you need to pass in is x and y. So the x coordinate first is going to be width over 2. So I'm going to position it in the center of the screen. And the y value will be height over 2. Okay, so now that's going to be in the center of the screen. And now we need to do self.vel. So this is the velocity our player is moving. So we're going to set this to vector value of 0, 0, because our player is not moving in the x or y direction right now. So now that we've done that, we need to say self.ac or self.acceleration, whatever you want to call it, is equal to self is equal to vec 0, 0. So that is pretty good now. We're going to set this to, now in our update we need to change it. So we need to say self.ac is equal to vec 0, 0. Okay, so right now we want to set the acceleration to 0 while it's moving. We only want to set it to when it's trying to stop. We want to give it the acceleration. Okay, so here we need to write down some equations of motion. Okay, we need to write those here. So I'm going to say self.vel plus equals self.vel plus equals self.ack. Okay, so we are going to, I need to put self here. So basically we will be adding we are going to be adding some acceleration to our self.vel. And then here is where we're going to be implementing the acceleration. We're going to say self.pos plus equals self.vel plus 0.5 times self.ack. So now that should be slowing down our player and giving it some sort of acceleration. So now when we move the player left and right, we need to say self.ack.x because we only want to be moving the x axis, but is equal to minus player ack. So now that should be moving left, and then we say self.ack.x is equal to player ack. So we're not doing any plus equals or minus equals. We're just going to be saying is equal to, because we're going to be moving the velocity. So that is why. So this is actually where we move it. So we move a player here. So because the velocity is how we move the player. Okay. So we do plus equals depending on the speed of our player. Okay. So now another important thing we need to do is we need to say self.rect.center. So remember the center point of our rectangle is equal to self.pos. So we will be moving the rectangle. So we'll just be assigning it to self.pos. So it will look like it's moving, but actually it's just replacing the image every time, but it's doing it really quickly. So let's run this and see. So now you can see our player is actually kind of going pretty fast. It looks like it's on ice. This would be pretty good physics if it was on ice, but I'm just saying maybe it's going a bit too fast right now. So we want it to be casually walking kind of thing. So we're going to actually have to apply some friction. So how do we do this? Well, first in our settings, I'm going to create a player friction variable, and we're going to set this to minus 0.12. So we don't want to slow the player down too much, but we just want to slow it down so it doesn't go too fast. Okay, so here in our equations of motion, what we need to do is we need to say, so right on top, I'm going to put down here, apply friction. So what we need to do is we need to say self.ack plus equals self.vel. So now we're moving the player, but then we're slowing down the velocity by timesing it by player friction. Okay, so now that should apply the friction. Let's see. There we go. So now it's actually going pretty good. Not too fast, not too slow, but just right. So now our player can get easily lost around the edges of the screen. So we want to kind of make it wrap around. So we want to make it go this way and come out this side over here. So it goes this way, comes out that side, but then if it goes this way, we want it to come out this side, okay? That's what we want to happen. So it isn't too hard. All we need to do is we just need to position it at another place when it goes off the screen. So we're going to say wrap around the sides of the screen. Okay, so we're going to say if self.pos.x is greater than width, so that means if it has gone off the left side, I believe. Yes, if it has gone off the left side, then we want to put it at the right side. We're going to say self.pos.x is equal to 0. So we're going to put it at the right side. And then after that, we're going to say if self.pos.x is smaller than 0, so if it has gone off the right side, we're going to say self.pos is equal to, we're going to set it to width, so it comes out the left side. And that should be pretty good now. Let's check. Okay, so that has given us an error. It says invalid rect assignment over here. So self.rect.center is equal to self.pos. Okay, so here I put self.pos is equal to width. So we need to say self.pos.x is equal to width. And now our player has gone off the screen and appears on the other side. So that's pretty good now. So now we should add some sort of gravity to our player. That won't be too hard. And then we're also going to be adding another sprite and we're going to be adding a platform. So a ground platform over here and a tiny platform up here. That's what I'm planning. So yeah, let's do that. So the adding the gravity is not hard at all. All you need to do is we need to go in settings. First we need to create a player gravity or player grav. And I'm going to set the player grav to be equal to 0.5. So it moves at a sufficient speed. So we are going to say self.act is equal to vec, and instead of passing in 0, we're going to put in player grav. So it will move down when even though it's on a platform. So it'll give a sense of gravity to the game. So let's see. Okay, so that has, oops, maybe I need to run again. There you go. So now it is moving down pretty good. So maybe we should speed up the gravity. So maybe about to 0.8, I guess. There we go. So it is just moving off the screen now. So yeah, that is pretty good. Okay, so now that we have done that, we should be adding some sort of platforms now. Okay, so what we need to do is we're going to be creating another sprite. So since this is a platform sprite, I'm going to be calling this one class platform, and this is going to be a sprite. So pg.sprite.sprite. There we go. So we need to initialize the class by saying def init, and in our initializing method we need to initialize the sprite itself. So we're going to say pg.sprite.sprite.init. We're going to pass in self, so it initializes our sprite. So in the init, what I was thinking is when we call the class, we need to pass in these parameters. So x, y, width, and height. So we're doing this now so we can put in the size of the platform we want. So we're going to say self.image is equal to pg.surface, and we are going to be passing in width and height over here. So now we can specify what size we want the platform to be. And then I'm just going to fill in the platforms with green for now. So I'm going to say self.image.fill, going to fill the thing with green. And then I'm going to add a rectangle. So self.rect is equal to self.image.getRect. So we put brackets at the end. And then we say self.rect.x is equal to x. So we can position the platform wherever we want. And then we can say self.rect.y is equal to y. So that is actually our platform class. Very simple. So let's add a ground kind of platform to our world, our simple world. So we're going to be adding a ground platform kind of thing. So in our new over here, we need to do it right here. Okay. So I'm going to create a new group called platforms. So self.platforms. So there we go. So self.platforms is equal to pygame.sprite.group. So this is still a sprite group, but this platforms will be in our all sprites too. So what we need to do now is we need to do this. So in our new section, we are going to be putting in our first platform. So I'm just going to say P1 is equal to our platform class. So we need to pass in parameters, right? So I'm going to put the x to, was it the x? The x to 0, okay? And then I'm going to put the y to height minus 40. So now that should be in the correct position. And now we're going to put the width, which is equal to width, so it stretches across the bottom of the screen. And the height will be 40, so it's pretty thick and okay. So now we're going to add it to the sprite. So we're going to say self.allsprites.add. We're going to be adding P1, and then we're going to add it to self.platforms as well. So self.platforms.add, going to add P1 to it. So this may seem frustrating, just always adding it, but don't worry, we're going to change that in the next video. But for now, let's see our platforms. So that's giving us an error. Module object is not callable. Okay, so it's a capital letter here, because Python is case sensitive, right? So let me just run this again. So as you see, our player literally falls off the bottom of the platform, which is not what we wanted. We want to kind of collide with the platform itself. So we are going to, for the first time, we're going to handle that in our update section. So what we need to do is we need to say, thankfully, when you're using sprites, Pygame has something called Sprite Collide. So we can calculate collisions easily without having to put all of that kind of numbers everywhere and different calculations and everything. We can just use Sprite Collide. So we're going to say hits is equal to Pygame Sprite Collide. So this will return a list, just like the keys.getPressed, but it's Sprite Collide instead. So we want to collide with the player, so self.player. We also want to collide with the platform, so self.platforms. And then we also need to put in a compulsory third parameter. Now this is whether we want to, as you can see here, it's saying do kill. So this means do you want to make the platform disappear, or the sprite, make the sprite disappear when you collide with it. So we don't want that to happen, so you're going to put false. But if you put true, it's going to disappear, and then our player will fall down. So we're going to say if hit, so if the player does hit a platform, we're going to say self.player.pos.y is equal to hits 0.rect.top. So why did he put hits 0? Now that basically means we put so hit 0 is basically the first platform that it hits. We're going to put our we're going to be putting our player on top of that platform. So let's check it out. So now you can see our player is actually kind of stuck in our platform now. It's stuck in halfway. So the reason it's doing that is because we haven't stopped the player velocity once it has hit the platform. So we're going to be saying self.player.vel.y is equal to 0. That should do a trick. Okay, so that did not do the trick. So let's just check why it is doing that. So here we write hits is equal to Pygame dot. So I went through the Pygame script and I noticed that it said self.rect.center. Now, as I told you, the center is the center point of our rectangle. So it is kind of getting stuck halfway through. So what we want to do is we want to put mid-bottom. Okay, so it's the mid-bottom that is colliding and not the center. So now that is pretty good now. So now I'm going to write down this. So what I'm going to write down is, so I am going to write down if the absolute value, so that means if the non-negative value of self.val.x, if it is smaller than 0.1, then I'm going to say self.val is self.val.x is equal to 0. So that should be adding more accurate acceleration and it'll be kind of nice. So back to our main. So I'm going to collapse this now. Back to our main.py. I am going to be adding another platform actually, because as I told you, I was going to be adding 2 platforms. So we can copy this now, so we don't have to add it over, keep on typing on the same thing over again. So we're going to say P2, and then we're going to add P2 to our sprite group. So what we want to do is we are going to be positioning this at width over 2 minus 50. So that should be in the middle of the screen now. And we're going to position it at height times 3 over 4. So it should be a little bit above our main ground platform. We are going to put it 100 pixels wide and 20 pixels tall. And that should work now. Let's check it out. So now we have this platform over here, and when we fall off, it is pretty good. So now there is no way to get up onto this green platform over here. So what we want to do is we're going to add some jumping. But I'm not going to do that now because this video is already getting pretty long. It's nearly 1 hour. So I'm going to leave that for the next video. So thank you for watching this video. If you like this video, please like and subscribe, and leave a comment below if you feel like it. If you have any comments or doubts, please comment them in the comment section below. And yeah, thanks for watching this video. In the next video, we're going to be adding some jumping graphics and maybe game over screen and start screen as well. So yeah, bye.